advantage there. Yes, so you like. Okay, Monday. So, with something that I was doing to show the trick come from Milan, and I was like, I think the most interesting stuff for a technical crowd is sorry, Venus. The most interesting stuff for a technical crowd, like you would be to what really working on the case studies, the things that really feed the company. We don't have a marketing department. We don't have, as you see on our website, we don't really care about showing cool graphics, but rather we built our we built our trademark out of what we do as a supporting the ecosystem. So the first one is with type, where I think we had a very substantial effect on the ecosystem. Cycle is a layer 2, which in Web3 is very interesting because they want to bring the realism-based rollup, right? Which is a very discussed topic in the infrastructure, the layer 2 space, but what's really cool about it is that it's a different way of scaling Ethereum while giving back the value to the validators that are to the core network. So on that side, I think there is a lot of interesting stuff. On top of that, there is the potential for interoperability and ways of doing it differently. I'm not saying that we couldn't do it with normal rollups. I think like the property of Tyco could enable for something more. But this has a problem, this sort of a huge problem, which is that they're constrained to a one block. So we actually have a tool which has some lower fees, but the UX is terrible at 12 seconds blocked. So we went to Tyco with a proposal saying, well, I think we can build a client for your rollup that has 2 seconds blocked. What that means is, follows the UX from many other rollups, hence the ability to have better UX than L1. How you can do it is with having a permission set of pre-confers, which is a permission set of proposers that can propose for a certain time, and then they, on round robin, get selected. This was the first iteration. I put it very clearly because in the case that is a permission set, you're not really moving a lot. You're moving from a fully based rollup setting to a more of a normal rollup with having this better UX, but less permissionlessness, right? So the next step of this work with Tyco is actually to enable permissionless sequencing, and permissionless sequencing with pre-confirmation. And we're working on it. It's a very tough design problem, yeah, something interesting we're doing. Some stats, we're building 3,000 Tyco blocks every day. We also built a Tycoscope, which is this monitoring for the first base rollup in production. It gives you a whole idea of like, the flows of value, how different players work on it. Here you can see the sequencer pre-confirms, call them however you want. In this case, were Chainbound, Nethermine, Gattaca, and Tyco itself. And we proposed blocks on round robin and made pre-confirmation and so on. Another thing we worked was with Ethereum Foundation. We worked with Ethereum Foundation to solve a problem that was very interesting, which was we need to understand how actually decentralized Ethereum is. And we've done it with this system that we called Ulisse, which was really just a crawler that would sort of look at the short-lived attestations metadata that you would get from the P2P layer and sort of try to estimate the number of validators per aggregated aggregator validator, right? I can go into the details of how we did this, but I'd say that the interesting stuff is that we were able, for the first time, to have a map that shows the actual validators on Ethereum, and again, not nodes, but validator, and how they're spread across the world. And it was reassuring to see that's actually decentralized. Then we work with Flashbot. We are working with Flashbot, and how we work in Flashbot is
to give some context, Flashbot has a block builder, a software that builds blocks and submits them to the MEV auction, like few relays that select the highest value blocks that get submitted to the validator. This happens at every block cadence, right? And they have their own, but their own has very interesting properties. And one of the interesting properties is actually that it runs nodes in TEs, that every node has the ability to sort of build cooperatively the block. So you could have untrusted parties collaborating on building a single block. It's a very interesting solution, in my opinion, in Ethereum, because it enables a lot of things that we didn't have before. One of which is, yeah, you could have higher value blocks, you could have collaboration on order flow auctions, you could have so many different things that single block builders and trusted block builders don't get to. And how we are supporting Flashbot in this case is in the networking part, right? All these TEs, in this case, right now there are 3 TEs, 3 TE nodes that run in 3 different regions, one in the US, one in Frankfurt, and one I don't know where. And they need to communicate between each other. Communication has an overhead. Communication has both fixed overhead, variable overhead, all these things that can be improved. And in the case of actually the MEV auction, the slot auction in this case, every milliseconds count. Like you could miss by a single millisecond every time and you will always lose your auction. So every single millisecond needs to be shaken off. And we're working to improve their networking stack on many different layers. So we added a whole new metric and logging system on the message propagation layer. We ported their code base from Go to Rust at the order flow proxy, which was this part of the code base. And we're also experimenting with new libraries, which with new networking libraries to reduce the end-to-end latencies of message propagation. And actually we are aiming to use MSGRS, which is our own open source messaging library that we've been building. And we're also doing many more things, but they're in the work in progress, and I didn't see fair to put it. Okay, this was like the part of, we called it advisory, we called it custom software development is where we really are able to see and expand our team continuously on this direction. And I'd say it's been very cool to see us starting from nothing and now being able to build things that are used by thousands of people or improve systems that are actually very, very innovative. On the product and protocol side, I cut a lot on the things that we've done in the past because, yeah, it's not that interesting. But I want to say what we are working on right now and the thesis that we built inside of Chainbound. The base thesis is that we are, as I said at the start of this presentation, at a cornerstone moment for adoption of a few cryptographic primitives that can have real effect on the adoption of blockchains. 2 that are obvious is obviously TE for verifiable and confidential computation, and ZK, in particular we see ZK-TLS a great use of zero knowledge to trustlessly prove data are authentic, right? And we are in the design spec of this, and we're building it in the open, and that's also why we're presenting it now, and it's really not in its final state. Like, it's very, very far from its final state. But the idea is dApps needs confidentiality, privacy to unlock new use cases. But if you're a dApp, you cannot really give up on verifiability, resiliency, and immutability. Not because these are cool features, but rather because, like, if your dApp has billions of dollars locked in a smart contract, the logic that lives off-chain and is the logic that is confidential and manages those assets cannot change, so hence cannot be mutable, or cannot be that it's not verifiable, or cannot be that at a point you cannot access the assets and so it's not resilient. So these are core properties that, in our opinion, are the only way to get to like real confidential computation on blockchains, but also that's actually used, right? Because there are a lot of options out there, but not really integrated into dApps. Why? Because of these reasons I just explained. So like, we are working on the ST coprocessor network that we think could be the solution. And we think it could bring a lot of primitives and tools for dApp developers to do a leap in terms of use case. I don't like to sound dramatic, but if you look at it in the last 2-3 years, the primitives and the things that have been built on DeFi didn't change that much. Like, we have DEXs, we have oracles, we have things that improved drastically. Like, DEXs became more efficient, Oracle became better, more efficient, with more things where you can get Oracle data from. But ultimately, the primitives are the same. And this is not because there's no creativity. There's too much creativity. But the problem is, the things which dApp developers can play with are limited. And this, we aim to bring it as a solution. We're fully in the designing stage of this. Nothing is set in stone, and I'm here over the next 3 days really to talk with all of you and discuss. And also we can give you access to our docs, and you can read it more and give your input. But like, the features that we see that needs to be there at a very, very high level are, first of all, an encrypted distributed database, right? You need a solution for this, for a dApp that has a confidential logic running inside of TE to fetch some data that are running in an encrypted database, and this database is only accessible by unauthenticated logic that stands in the TE, right? That's the first thing. The database needs to be resilient, immutable, verifiable. Otherwise, you could have, I don't know, let's make a simple example, a vault that has $1 million, and the encrypted database keeps track of the balances of everyone in that vault, but then you lose access to the database, and now no one knows how much they own, right? That's a simple example where it needs to be encrypted, but it needs to be verifiable, and so on. We need to use TE as stateless pipes. I defined it in a sense, like the TE using hardware keys and so on, as we've seen. I don't know if you read. Anyway, there are a few protocols that actually, because of an upgrade of Intel, they lost access of user assets because the keys were actually the one used to sign transaction and were the hardware keys. So we need to move away from these things where the TE does everything to rather saying we use the TE as a sort of, again, stateless pipe where we use other type of key management solutions. And this key management solution could be reinforced by MPC and so on, that are things that, again, in the docs we can provide more things. And then the other things is, obviously, we can't have a logic that can be upgraded by a dev whenever they want, so there needs to be on-chain upgradability, both for the system, so for the overall thing, and the modules. And finally, the network needs to be permissionless, otherwise, yeah, always the same problem that you would have a single point of failure, or you would have many other things that wouldn't make it as resilient as it needs to be. So this is, at a high level, something we are incubating at Chainbound. We are working, again, in the open, happy to talk about it. This, I think, also explains the grant that we put out here. The grant is really to, yeah, people are interested in working in this space. We're not looking to build an ecosystem, as the product is not there. But rather, we are looking for people interested in joining. We have a lot of open positions, and I think we have also ambitious plans as a team. I missed this slide, but this slide mainly explains, like, okay, but what can you actually do with this thing? And there is confidential computation, verifiable computation, encrypted state, and secret management, right? So few things you can do is you can enable smart contract to process confidential informations, manage user credential trustlessly, right? A simple example is, what if you have a smart contract that requires to check if you are an Italian citizen, right? Well, it's impossible to do it as of today, but in a solution like this, you could have an off-chain logic that's confidential that does a request to the database of the Italian government. Now, we can find many different ways of doing that, and just says, true, you're Italian, right? But it needs to obviously be with all the properties we said before. Then it needs to be verifiable, so we need to enable protocols to move off-chain. And I make a simple example. We did a lot of product research and spoke a lot with with dApps about this. And one of the people we spoke with was actually the CTO at Lido. And he said, look, we have a very, very, very complicated logic on chain. Like we need to do all this rebalancing of fees and so on. And we're doing it on chain, not because like it has to be on chain. It's just because we don't have any other choice. Like it has to stay there. It needs to be verifiable because we're managing a lot of money. But if we could find a way to do it off chain and that be extremely verifiable, we would do it. We would save literally millions of dollars a day. They do rebalancing continuously, right? And that's an example. Encrypted state. You can enable private state in smart contract. I made the Shield Vault ownership tornado style, the example I made before. That's a use case. And then you can have secret generation and management, right? Which is, there's so much literature on this coming out lately. And you can check this paper about liquefaction, for example, or account encumbrance. There are a few very interesting primitives that all of this enables, which is, well, what happens in the moment that you generate a private key in a TE and no one has actual access to it, and you can put privacy control on top of it or policy controls on top of it, not privacy, privacy. A simple example is Prive is doing that, right? They do it in a different way, but that's exactly the same thing, like the private keys inside of TE, and then they give you access to authentication with different methods and policy controls. But what happens if instead of being a simple embedded wallet, it could be a wallet you fully own and you can trade, right? What happens if you have policy control on this wallet for 2 hours and then you can sell it or you can do something else. So that's an interesting thing, and yeah, one of the use cases. Finally, we're hiring. I'm here to speak with people to learn a bit what you're doing. And if you're interested in learning more about what we are doing, I hope I was clear enough. And again, we're a small team. We are really happy with what we're doing. And if anyone wants to do something similar, just come. I'm here all weekend. And yeah, that's it.